So a Box-Whisker plot has 5 numbers. We call it Box-Whisker because there is a box. And it's got whiskers. Very ingenious.
Wow.
And it's, wow, right. There are 5 numbers that we need to create this. So each of those 5 numbers belong to these magical dashes. So there, and there. If you have to take a guess, what are those 5 numbers?
0, 25, 50, 75, 100.
And typically, in practice, people would probably put it as Q1, Q2, and Q3. Good. So that is a Box-Whisker plot, and there are some advantages in having a Box-Whisker plot. Excel can do this easily. Most software can, your calculator can, but as far as this class is concerned, I'm not going to ask you to create one on the exam. It's all about interpretation. So I'm going to draw 3 of them. Of the 3, which has no skew? A. Now, how did we determine that?
Symmetric.
Symmetric. What are symmetric? What is symmetric?
The whiskers.
The whiskers, right? The length here and the length there are kind of identical. So balanced whiskers. Number 2. Does it have a skew?
Yes.
Specifically what kind?
Negative or to what?
Right.
We're not playing Beyonce to the left and right. Which one is it?
Should be so right. Yeah. Yeah.
Right? To the right. And the last one,
Skew left.
skew left. Can't say it, but something like that. Of the 3, which one do you think has greater variation? Too much variability.
Probably B.
Just B or B and C kind of section.
C and C.
B and C, right? I just want an approximate answers. So B and C seem to have greater variation. And how do we recognize that?
The unbalanced whisker.
Unbalanced whiskers, and also the length of the whiskers when you combine, it's a wide range. So you know, this curve, it comes from a histogram. So some people would prefer a histogram, others would go for a box and whisker plot. In practice, I would always use a histogram and a density. It's very scientific, technical. Business people most often use box and whisker because it's very straightforward to see. Once again, to keep things simple, if I went to a business group and start talking about this is a skewed density, it can be approximated by gamma, they're not going to understand, right? Got to keep it simple. So skew, bars, etc. So box and whisker plot, oftentimes business people, scientists, some they use. Any questions on that? Alex, question?
Sorry, I was like.
So we have the data entered, which is vacation days, second mode, exit, all that. Go over to calc. It's one variable statistics. And we know the calculators differ, the older model and the new model. Mine is older.
You put on mode again, I'm sorry.
No, it's just second mode to exit.
Oh, gotcha.
So let's see, what is the first number?
Mean.
What about the fourth number?
Does that standard deviation?
Standard deviation, specifically, which one?
There was yes.
There are two.
I don't know. Sample.
Sample, which one's the population?
Exactly.
The next one. We have 20 observations. Minimum is 0. Q1 is 2. Median is 4.5. Q3 is 6.5. Maximum is 10. Good. Long time ago, when we were talking about measures of center, I said if the mean is closer to the median, then the chances are there is blank. Hunter?
Less skew or no skew?
Less or no skew. Let's see if that is the case. So your calculator can do a box and whisker plot. I say make use of it when you do your homework. Your calculator gives you Q1, Q2, Q3, everything. So make use of it.
Where's Q?
Second, start plot. Mine is already on. Select one. And if yours is not on, switch over. On.
Yeah.
Do you see Box-Whisker plot?
Yeah.
So second row, there are two types. One that's got dots, the other one is a regular Box-Whisker plot. The one that has dots indicates that the dots are outlines, things that you should remove. The other one's not going to tell you if there are outliers or not. Does that make sense?
So which one should you should?
I'm going to go for the regular one.
Okay.
So that's the regular one. And head graph. Yeah, we don't see anything, so what do we do? Zoom 9. And that's what we get. You may think, what is this? It's a long line. It's because it's at 0. That's the axis. So 0 all the way, and then you've got the last number. Do you see a skew?
Slightly.
Slightly, not too much, but there is a little bit of skew. And it is leaning more toward the right. Yes? And look at the data and tell me which number is causing that.
The 10.
The 10. The 10 is the one that's creating problems for us. So I'm going to go back to plot and select the one with the dots. To see if, computationally there is a way to do it, I'm going to go over that. If the calculator determines that 10 to be an outlier, it doesn't. So even though it is way off, it doesn't consider 10 to be an outlier. But how does it do that? I'm going to show a procedure for that. Okay. Are we clear?
Yeah.
Yes? Okay. While we're at it. It's coming back. It's quite okay. So how many? That's your So here we have a bunch of ages, and we can make use of the calculator to find Q1, Q2, Q3. Q1 is 43, Q2 is 49, Q3 56. X bar is 49.03. X bar is close to the median, so chances are it's got little to no skew. That's great. Let's go on to these two first, then we can move on to 33 and 34. Which ages are above the 75th percentile? Anything above 56. Okay, great. 57 is 1. 66, 65, 61. Yes. That's it, right?
About 56,
6.
or 61.
We're not including the 56.
You have another 61 in there too.
Yeah, and there's another 57.
You don't.
No, we just want the ages.
Oh, you don't.
I don't want the
You don't want.
counts. Yeah.
Okay.
It's just asking which ages are, about 75.
Okay.
These ages.
Right.
57, 61, 65, and 66. Likewise, which ages are below 25? Well, P25. 43, let's see. 28 is 1, 35, 38, 40. I think that's it, right? Do we see anything else below 43? I see a 41.
42.
And 43. Okay, mind you, I'm not writing all the observations that are below P25. I'm just writing which ages are below P25. The ages below P25 are these. Okay. What would that mean? 25% of executives will have an age less than 43. About 50% of them will have an age less than 49, greater than 49. Only 25% of the executives would have an age greater than 56. Does that make sense? 75 below, 25 above. We want to find the percentile that corresponds to an age of 40. In other words, we are finding P40. That's a percentile. It is also a decile. Do you agree? It is in tens. How do we find it? Number of observations below,
N equals 0, right?
come again,
Or do we N equal to?
below 40, I'm sorry, they're trying to find the percentile. So x is 40. So number of observations below 40, your book uses exactly below.
Okay.
So we just start counting. But even before you start the problem, do you think the answer will be or could be 28?
No.
Alex says no. Could it be 52?
No.
Could it be 71? No. Why not? Why can it not be 28?
Because the Q1 that is 25 is already 43.
Already. Yeah.
Quick reference. So 43, 49, 56, right? So 43 and 49 is right here. Those are the ages. So 40 has to lie below 43, somewhere over here. So if that is P25, that value has to be less than P25, in the sense P20, maybe P18. We will see. How many of them are below 40?
3.
Only 3. So 3 are just 30. Multiply by 100 to get a percent. I'm trusting Hunter. So it looks like it, right? It's right here.
10.
So 10%. So 10% of the observations lie below. Now we've got to include the repeating ones. Did you include the repeating ones? Every single observation that is below.
Yeah. There's only 3.
No repeating 28, no repeating 35, no repeating 38. Okay, good.
There's only 3.
So 10%. So 40 years old. Is P10. But 10% of the executives would be less than 40 years old.
Is P10 10 or 40?
40.
Okay.
So, no, 40 is somewhere over here. Less than P25. So, good.
Just, I want to clarify, we never include 40 into that value set. It has to be 41.
Yes.
Okay.
Again, the book strictly says less than 40, excuse me, less than the value x,
Okay.
but you can say less than or equal to, just rounding, but I'm not going to do all that.
All right.
Stick with book.
All right.
I hate to give you that answer, but less confusion that way. But there are multiple ways to compute that percentile. Okay, let's give number 34 a try. So we are trying to find the percentile that corresponds to 56 years old.
75.
We have the answer ready, it is 75. Made it easy for us. Okay. So let me ask another question. The percentile that corresponds to the age 60. I'll give you a few minutes, but even before you start, could it be P10? Could it be P14? Could it be P50?
No.
Could it be P82?
Yeah.
Maybe it's a guess, right? It has to be above 56, perhaps. It could be P82. To find the accurate value, we're going to make use of the formula that we know. How many of them lie below 60? Including the repeating ones. How many?
Quick
Yes.
question. To find the percentile below 60, since it's one of the numbers that's higher up, can we find like the percentile above
Yes.
Subtract.
Put a star right next to your own question. That's called a complementary rule in probability.
Yeah.
That is definitely 80 something.
It's, yeah, it's 86.7 rounded up, which would be P90.
87. Nearest whole number.
Wait, what?
Nearest whole number.
Okay,
So I think you confused.
so why in that first?
So earlier, when I said, we'll just say P60, because if you're going to convey it to the public, we don't want to, go through P86.7, P87, and so forth. Simply go to the nearest decile and give the decile value. But in this case, we are trying to be as specific as we can because we're all smart.
Okay,
So,
So
that didn't
always
come out
be-
right. It wasn't politically correct.
so be as specific as possible.
Be as specific as possible.
All right.
So if you ask me, I would say P86.7 will be 60,
Okay,
right? But if you want to be a bit more simplistic, you would say P87 is 60.
okay,
You rounded it to the nearest
all right.
whole number. Does that make sense? So when you answer in my lab, my math lab, or even in the, on the exam, it'll probably say, to the nearest whole number. So
Okay.
your answer has to be P87.
Okay,
Does that make sense? Any questions? Okay,